All right, so today we're going to be looking at quadratic transformations. We're going to be starting off with our quadratic parent function, which is f of x equal x squared. Okay, so you talked a little bit about transformations in middle school where you had reflections and slides and translations and all that. That's pretty much the same thing we're doing here, except we're using a quadratic or a parabola. So when we say x squared, that's going to be our original function that we're starting with. And from there, we're going to be performing our different transformations. Okay, so we're going to have our equation in vertex form. And vertex form is f of x equals a times x minus a squared plus k. And vertex form also gives us our vertex. So where it says h and k, that's actually going to be the coordinates of our vertex. Also, each letter in this equation, meaning the letters A, H, and K, will tell us the type of transformation we have. And I'm going to show you in a second using this application I have open. But your A transformations, that's going to be your vertical stretch and vertical compressions and also vertical reflections, okay? And I'll talk about this notation to the side in a sec as well. And then your H is going to be your horizontal shifts. And then your K is going to be your vertical shift. Okay, so I'll start with A. As you see right now, looking at the graph on my left side of the screen, I have an equation, and this is my parent function. So this is f of x equals x squared, that original function. So if I have an a value that's greater than 1, notice how what my graph is doing. Okay, you should notice that it's getting smaller or it's getting more narrow or more thinner. Those are all the type of words that you can use. But what this officially is called is a vertical stretch. Okay, so you need to be able to look at one graph and look at the next graph and say, okay, this is a vertical stretch or whatever that transformation is. Okay, so when a is greater than 1, it's going to be called a vertical stretch, and this is what it looks like, the purple graph. When I have a compression, that's going to mean that our a is greater than or equal to, or sorry, between 0 and 1. So a is greater than 0 and less than 1. So that's going to be like our fractions, like our 0.5s and our 1/2s and so on and so forth. So let's get back to our parent function. And here I have an a value of 0.25 or 1/4. As you see, this graph just got wider. Okay, since it's wider, we're going to call that a vertical compression because vertically is kind of being smushed together, meaning it's being pressed together. So that's getting wider. So again, we call that a vertical compression. Okay, our last one for A is going to be our vertical reflection. We know from middle school, reflect means that it's going to be like a mirror. Okay, so when my A value is negative, notice how it flipped over the x-axis. So that x-axis acts like the mirror. So it's going to be called a vertical reflection over the x-axis. Okay, and that's it for our A transformation. All right, with our H, okay, that's going to be our horizontal shifts to the left and to the right. As my H value increases, it's going to be going to the right. And as my H value decreases, it's going to be going to the left. Okay, so when you see a graph like this, you need to be able to identify that it's a horizontal shift left or right. One thing you'll also notice about H is that the formula is a negative, meaning when you look at an equation and you try to describe the type of transformation, it's always going to be the opposite. If you look at the bottom on this screen, you see here you have, it went over 3 units to the left. But if I was to change this out, this will actually be x plus 3. So whenever you see x plus something, that's actually going to the left versus what you would think. You would think it will go to the right, but it's actually going to go to the left. And you'll see more examples when we look at that in the practice today. And then our last one is going to be our vertical shifts up and down. So as my K increases, it's going to go up. So that one is actually true to the operation because my formula is a plus sign. So if it's positive 2, it's going to go up 2 units. And if it's negative, it's going to go down however many units that we put it on. Okay. So again, you need to be able to know how to look at your original graph, know how to look at your transform graph, and be able to tell the type of transformation it is. If you can do that, you'll be pretty much good on this concept. One more thing you may want to know how to do for the practice today, and I'm just going to show you an example. They may give you a graph, but they also may give you an equation. So they may say compare our parent function, which is x squared. So I'm going to type that in. And they may say compare it to x squared plus 4. Okay, so when it's like that, you need to be able to know how to type in both equations on that same graph. And then I would say, okay, from the blue to the red, it went up 4 units. Okay. So if you know how to do all those things, you'll be good on this concept. One thing about this concept is it's very visual. So you have to see it. It's not where you got to add and subtract and do all these things like some of the other concepts. You just have to make sure you see the transformation that's happening.